In the last video, we looked at how we can use this ratio chart to solve questions in which we're given some ratio and we're given some actual value. In this video, I want to look at what I think is the biggest benefit of this chart way of thinking. And that is not so much using the chart to solve ratio questions for values, but recognizing the kinds of info that you could use the chart for to solve values. And that kind of thinking, of course, is most useful in the data sufficiency question type, knowing that you could do something without actually doing it. So the chart tells us that if we have a ratio and we have some actual value, we can solve. And of course, that can be very helpful in a wide range of data sufficiency questions. For example, maybe our question stem is something like this. If the ratio of x to y to z is 7 to 8 to 10, what is the value of z? So already we're given a ratio, so you might already be thinking about the chart. If we just get some kind of actual value, we'll be able to solve for all the other actual values. So I guess I want you to think about that while we look at the statements, and I want you to see if you can determine whether or not they're sufficient without doing the calculation. So statement number 1, x plus y plus z equals 200. Statement number 2, let's see, we're asked about z. Statement number 2 might just give us information about x and y. So let's have statement number 2, x plus y equals 120. So if you were thinking about the chart as I put these statements down, you might already have a pretty good sense of whether they're sufficient or not. The thought process might be something like this. We'd say, okay, STEM gives us a ratio, and we might be already thinking, all right, we've got a ratio. That means we could throw down some kind of chart like this and put X, Y, and Z and the ratio world numbers up here. And then we're just waiting for some real world value to put down here. Maybe it's X, Y, or Z, or maybe it's something else for which we can add a column. And statement number 1, sure enough, gives us an actual value. We get x plus y equals z, x plus y plus z equals 200, and we could totally just add a column for that. We could add a total column or an x plus y plus z column, add a 200 down here, figure out the analogous component in the ratio world, and get our multiplier and so on. And once we're comfortable with the chart, we recognize pretty quickly that statement number 1 is sufficient. What about statement number 2? Same thing, right? Statement number 2, we get an actual value, which we could, if we wanted, we could, build that ratio chart and put that 120 in an x plus y column, get our multiplier, and solve for everything. So statement number 2 is sufficient. And once we're comfortable, it just takes a couple seconds to recognize that the answer to this question is D. And if you're still not confident with the chart, if you're still not completely sure that this would allow you to solve it, well, you could certainly, it wouldn't take too long to actually use the chart to solve for a value, although ideally, my hope is that by the day you're sitting for the GMAT, you'll be comfortable enough with the chart to know that this would work. But in practice, I don't want you to think of this chart as this long, cumbersome thing to do. So if we wanted to prove it, we could go to statement number 2 and throw down our 3 rows. And since it's a 3-part ratio, 3 columns, x, y, z, and our ratio numbers are 7, 8, 10. Our actual value is x plus y, so we're going to need a new column for that. New column, the x plus y column, and this is in the real world, so we'll put it down here, x plus y. The actual value is 120, and what's x plus y in the ratio world? Well, 7 plus 8 is 15. So we've got our analogous pieces. We can find our multiplier. 15 times 4 is 60, so 15 times double that, or 15 times 8, is 120. And there's our multiplier. So for z, 10 times 8 is 80. So if we had to use a chart, it doesn't take too long to actually solve. Although once again, what I really want, the way the chart I think is most useful, is just for that visual way of knowing, of intuiting what kinds of information would be sufficient. And again, if we have a full ratio, and then we get some kind of sum or difference or total, we will be able to solve for everything.